hopefully you've mastered balancing equations by now and are ready to start using those balanced equations to look at mass calculations. So, when we take a look at a formula such as this or an equation like this, note it's balanced. Everything's good. We're good. We can now talk about relationships between the different chemicals just as we could before within a formula. So for example, you could say that for every mole of CaCl2, this reaction produces 2 moles of NaCl. Just as we could say there's 2 NAs for every NaS, we can make these relationships for everything that's here in the balanced equation. So for 1 Na2S, that produces 2 NAs. Or for 1 Na2S, that's 1 CaS. This is one way to provide our own inequalities from any given formula so that we can say different types of relationships as we have within the formula. Okay, so here's what I mean by that. Using that as an example, 1 CaCl2 produces 2 NaCl, therefore we can say 1 mole of CaCl2 is over 2 moles of NaCl, or vice versa. We can reverse that as well. So we can basically say that those two things are equal in a given balanced equation, and then use that for the molar equivalent. So that's what we refer to as a molar equivalent. What you're saying here is that for every one of these, there's 2 of these. For every one of these, you can have 2 of those. Whatever type of relationship you want to use there, you need to for a particular problem. So, as an example, if you start with 2 moles of CaCl2, how many moles of NaCl will be produced? Well, you simply say 2 moles of CaCl2, and then you use your inequality. So 2 moles of NaCl over 1 mole of CaCl2, that means that you will produce 4 moles of NaCl. That's nice when you have really nice and round numbers. They're really easy to figure out. But when you get into a more complicated scenario, this is when things get difficult. It's very, very, very important. You cannot equate any values other than moles by a balanced equation. You must first perform any type of calculation necessary to get things in moles. The only relationship you have between elements or compounds is in moles, so don't overstretch yourself there. So here's a way to think of that. Say that you have grams of something. You use the molar mass of whatever this is to get you to moles. Then you can use the molar conversion through the molar equivalent. Okay, so from moles of A to moles of B. So in that last example, that would be between CaCl2 and NaCl. And if you need to, you can get the grams of B as necessary because you have the molar mass of B. Now keep in mind, molar mass of A and B are different because they're different things. This is the way I look at this guy. He's a train. This is like Grand Central Station. You got to go through the mole-to-mole relationship. If you're given moles to begin with, you can find moles, you can find grams. You don't have to get off at this stop. You can keep going. Or you might have gotten on earlier. Maybe you start with grams and you have to go to moles and then do all of this. That's fine. This is something that's necessary though. This part, you got to go through it if you're going to go from one thing to the other. So, make sure that you do it that way. If you have any deviation, I wrote it here. It's going to be a crash, so don't do that, okay? So as the first example, say that you have 5 grams of CaCl2. If you fully react that with Na2S, how many moles of NaCl will be produced? So in other words, this is mentioned to say, hey, you got plenty of that stuff. Don't worry about it. Figure out how much you would have from this. So first we have to figure out the molar mass of CaCl2. So let me go back and show you. You're starting here, and you're going to get off here. Okay. So 5 grams of CaCl2. Do that molar conversion so you have moles of CaCl2, and then the relationship between these two we saw on the first page. So NaCl to CaCl2 is right here, and you figure out how many moles that way of NaCl you have. As another example, if you have 15 grams of CaCl2 and you fully react that with Na2S, how many grams of NaCl will you produce? This is the same problem, the only difference is you're going further on the train. Instead of getting off here, we're going to get off here. Now what that means though is that you need to have the molar mass of both NaCl and CaCl2. Remember, here's the molar mass of one, here's the molar mass of the other. We already figured out the molar mass of CaCl2, so we figure out the molar mass of NaCl. We've got that. Okay. So 15 grams, and here we convert it into moles of CaCl2. Then here's your molar equivalent. Here we go, is going back to the grams of NaCl for the molar mass there, and that tells you how many grams of NaCl you can produce. You absolutely have to practice this or you will be completely lost. So make sure you do that. Thank you.